A sea of debris, the growing threat of space junk and our fight to save space. Introduction, the invisible danger above us. Imagine looking up at the night sky, seeing the stars, satellites, and the distant glow of the International Space Station, ISS. But hidden in that vast darkness is an invisible threat. Millions of pieces of space debris hurtling around Earth at speeds of 17,500 mm per 28,000 km/h. This isn't science fiction, it's a real and growing crisis that could end space exploration as we know it. Today, we're diving deep into the alarming reality of space debris, the risks it poses to our technology, the groundbreaking solutions being developed, and why this is a problem we all need to care about. 1. A sea of debris. How bad is it? The sheer volume of space junk. Over 128 million pieces of debris smaller than 1 centimeter orbiting Earth. Around 1 million pieces between 110 centimeters. 36 to 500 plus tracked objects larger than 10 centimeters. Dead satellites, spent rocket stages, and fragments from collisions. The Kessler Syndrome. A nightmare scenario. In 1978, NASA scientist Donald Kessler predicted a terrifying chain reaction. 1. A single collision creates thousands of new debris fragments. 2. These fragments collide with other objects, creating even more debris. 3. Eventually, low Earth orbit, LEO, becomes so cluttered that space becomes unusable. Satellites, the ISS, and future missions could be destroyed. We're already seeing early signs of this. In 2009, a defunct Russian satellite collided with an active US satellite, creating 2,000+ new debris pieces. In 2021, Russia's anti-satellite missile test added a 500+ trackable fragments, forcing the ISS astronauts to take shelter, visualizing the problem. If you could see Earth's orbit, it would look like a swarm of bullets, each capable of destroying a satellite or spacecraft. 2. The threat to our technology. Satellites under fire. Space debris isn't just a theoretical danger, it's happening now. Communication satellites, like SpaceX's Starlink, face constant risk. GPS systems could fail, disrupting navigation for planes, ships, and smartphones. Weather forecasting satellites could be damaged, making storms harder to predict. The ISS, dodging bullets in space. The ISS has performed over 30 debris avoidance maneuvers since 1999. In 2020, a piece of debris punctured the ISS's robotic arm, proving even small objects can cause major damage. The economic impact. Replacing a single satellite costs hundreds of millions of dollars. A major debris cascade could collapse global communications, costing trillions in economic damage. 3. Navigating the debris field. Can we clean up space? Active debris removal, ADR, the Space Cleanup Mission. Scientists are developing high-tech solutions to capture and remove space junk. Remove Debris Mission 2018 tested a net, harpoon, and drag sail to deorbit debris. ESA's Clear Space 1 2025, a robotic claw designed to grab and remove large debris. Japan's Astroscale, developing magnetic capture systems for dead satellites. Designing satellites for a cleaner future. Design for demise. Satellites that burn up completely on re-entry, less explosive fuel to prevent breakups. Self-removal systems, deployable sails or thrusters to push dead satellites out of orbit. 4. The future of space exploration at risk. If we don't act now, space launches could become too dangerous due to debris collisions. Mars and Moon missions could face higher risks from orbiting junk. Satellite internet, like Starlink, could fail, cutting off global communications. The need for global cooperation. Space debris is a global problem. No single country can fix it alone. We need stronger international regulations on satellite launches and anti-satellite tests, mandatory debris removal for defunct satellites, sustainable space practices to prevent future pollution. 5. Our role in protecting space. You might think, I'm not a scientist. How can I help? But everyone has a role. Stay informed. Share videos like this to raise awareness. Support space sustainability initiatives like the UN's long-term sustainability guidelines. Advocate for policies that hold companies and nations accountable for space junk. The big question, will we act in time? Space is our shared resource, and right now we're treating it like a cosmic landfill. If we don't act, we risk losing access to space forever. Final thoughts, a call to action. The clock is ticking. Will we clean up our mess, or will future generations look up at a sky